All right, so for atmospheric system feedbacks, we've got climate forcings and feedbacks. So Earth's climate system and therefore its surface temperature are controlled by sunlight, which includes forms of electromagnetic radiation other than just visible light, such as ultraviolet UV and infrared IR radiation. For Earth's surface temperature to go up, one of three factors must happen. One, an increase in incoming sunlight due to changes in the sun's activity. Two, a decrease in how much sunlight gets reflected from the surface back out into space. Or three, an increase in how much of that energy is kept by greenhouse gases. These factors driving the climate are called climate forcings, and there is a large number of Earth system impacts and feedbacks that result from them. Tropical deforestation. Removing large portions of tropical rainforests generates both cooling and warming climate forcings. The bare ground reflects more sunlight back out into space than the highly absorbing forest. So this has a cooling effect. However, a larger effect is the warming due to the release of the forest's carbon dioxide into the atmosphere and the absence of those trees that otherwise would have continued absorbing carbon. So the net result of deforestation is warming. All right, so now we're looking at albedo of various surfaces. What are the albedos of different types of surfaces? So from about 32 to 85% snow and ice. Snow and ice have high albedos. Fresh snow reflects the most sunlight. Glacier ice is translucent, so it has a lower albedo because it absorbs more sunlight. And then from 36 to 77%, we have clouds. Clouds are generally more reflective than Earth's surface, so an increase in cloud cover has a cooling effect on Earth. From 6 to 8% for water, we have liquid water is very transparent, so it absorbs nearly all incoming sunlight, reflecting only 6 to 8%. From 21 to 44%, we have sand. The albedo of sand varies greatly. It is much higher for dry sand than for wet sand. From 6 to 34% soil. Dark, wet soil absorbs most sunlight, but dry soil is very reflective with an albedo of 25 to 30%. From 6 to 25% is vegetation. Vegetated grounds have a low albedo, absorbing most sunlight. This varies for forests, meadows, and crops. Replacing forests with croplands has a cooling effect on the temperature. Albedo is the proportion of incoming sunlight that reflects off of an object's surface. On Earth, it is an important factor for retaining solar energy and therefore for climate. Albedo varies for different materials and also by incident angle. It increases as the angle of light relative to the surface increases and so is naturally higher at Earth's poles. Higher albedo means that there is more energy that's reflected, and lower albedo means there is more energy absorbed. All right, so for 21, they want you to construct an explanation for why croplands would have a higher albedo than forests. Albedo is the ability to reflect solar radiation back to space. Lighter colored surfaces such as croplands, reflect more radiation, which increases albedo. Darker surfaces, such as forests, absorb more light, which lowers albedo. Amelia. All right, so for evaporation feedbacks, an increase in Earth's temperature causes an increase in evaporation and precipitation as the warming of ocean water increases evaporation from its surface, and warming of the air increases its capacity to hold water vapor. While increases in temperature and in water in the atmosphere produce both cooling and warming feedbacks, the net result is a warming effect. Cloud forcing. Though clouds have a net cooling effect during the day and a net warming effect at night, the overall effect is warming, providing a net reinforcing feedback for atmospheric warming. So over here, in this image, you see an overall cooling effect during the daytime. Clouds have a cooling effect because cloud tops reflect some sunlight, mostly visible wavelength, back into space. This is a counterbalancing feedback. Okay. In this image, we have a warming effect. Day and night, clouds absorb a portion of the long wavelength infrared radiation emitted from Earth's surface. The clouds re-emit the infrared radiation, warming the atmosphere. This is a reinforcing feedback. All right, so for question 22, it says jet airplanes create long, straight clouds called contrails. How could you change the schedules of airplane flights to reduce their warming impact? So during the daytime, clouds have a cooling effect because cloud tops reflect some sunlight back into space. Clouds have a net warming effect at night. Hence, airplane flights should be scheduled during the day when the clouds have a net cooling effect. All right, so how currents work. Density differences between the cold and salty polar waters and the warmer equatorial waters drives the global convection cycle of deep ocean currents in the Atlantic Ocean. Ultra saline water created in the Atlantic Ocean, ultra saline water created when sea ice forms joins the cold and salty northward flowing surface water to form the North Atlantic deep water current that drives Atlantic Ocean circulation. So, what could weaken ocean currents? Buoyant fresh water from melted glaciers stays at the surface and blocks the northward surface currents, slowing down the deep convection cycle. So over here you see the melting glacier, the warm surface currents, the buoyant water. And I forgot to mention up here you can see the ultra saline water, the cold salty surface, and then the North Atlantic deep water currents, and then the warm equatorial water. All right, so the ocean and carbon dioxide. The ocean is involved in several feedbacks affecting carbon dioxide in the atmosphere. Ocean waters provide a strong counterbalancing feedback to global warming by absorbing CO2 from the atmosphere, reducing the greenhouse effect. About 30% of the CO2 that humans have released in the past century have been absorbed by the ocean. However, reinforcing feedbacks also exist. When ocean water warms, it can hold less dissolved CO2 than it otherwise would. This means more CO2 in the atmosphere and more greenhouse warming. In addition, as water at the poles warms, the difference in temperature between equatorial waters and polar waters decreases, slowing the pattern of global ocean circulation and reducing the ocean's ability to remove CO2 from the atmosphere. So for question 23, you have probably had the experience of leaving a cold, bubbly soda out in the open and finding that it had gone flat when it warmed up. The bubbles are CO2. Explain how this phenomenon can be used to model the ocean's ability to store CO2. So when ocean water warms, it can hold less CO2. So up next, we have biomass feedbacks. The biosphere provides a strong counterbalancing feedback for global warming because plants absorb carbon dioxide. The more carbon dioxide in the atmosphere, the larger the biomass of the biosphere becomes, removing about a quarter of the CO2 that humans release into the atmosphere each year. It is unclear how long this feedback will exist. Only about 45% of the CO2 that humans release into the atmosphere stays there. About 30% is absorbed by the ocean and 25% by plants. Human release of CO2 has more than doubled in the past 50 years, but plants and the ocean have removed more than half of it. Biomass absorption varies with climate fluctuations. The biosphere is estimated to contain about 550 billion tons of carbon, mostly in forest trees. Each year, plants produce new biomass containing over 100 billion tons of carbon. So this graph shows carbon dioxide and the Earth image. On the y-axis, we see the CO2 flux in gigatons of CO2 per year. On the x-axis, we see the years from 1880 to 2015. This purple, the lighter purple over here, represents the fossil fuels in industry. The darker purple is the land use change. This right here is the land sink, this area, and then the lighter orange is the atmosphere, and the red or the dark orange is the ocean sink. So question 24 asks, describe what humans can do in the future using the biosphere to reduce CO2 levels in the atmosphere. So humans can plant more trees that will reduce CO2 levels in the atmosphere. Some other acceptable answers are, again, we already talked about planting more trees, but a second acceptable response would be reduce CO2 emissions through combustion of fossil fuels. And a third acceptable answer would be anything that removes CO2. All right, that is all. Any questions?